Hello, class. Welcome back. Hope you guys are all having a great week this week. I don't know I haven't really seen exactly how the weather's been going over there in San Jose, but it's been actually a beautiful fall over here. The leaves are changing colors. It's just gorgeous right now. It's like 70 degrees, I think, the last 3 days. So, and sunny. It's just honestly kind of reminds me of California weather. So anyway, hopefully it's as gorgeous over there in California as it is here, which it's usually always gorgeous there. So I'm betting that it actually is. So, but this week we're going to be going over the responses to climate change, kind of an extension to the lecture on the terrestrial carbon and the terrestrial carbon reservoir. So the first thing we're going to look at is this image here from the 2007 IPCC report. I could not find in a reasonable amount of time the current one, so we're just going to look at the 2007 one. So first of all, this is going to be the multi-model projected patterns of precipitation changes. You're going to see here, this is the percent of precipitation change. To the right, we're going to have more moisture, more precipitation, and to the left is going to be drier, less precipitation. And you're going to see that these dots right here, these dots are showing the confidence in the models. Now, there would be more of confidence in the models like currently than in 2007. So that's going to be basically the main change between them. Let's see. So the first thing I'm going to show you is that the places here in the North Pole and the South Pole, oh, I'm sorry, I forgot to mention that on the left-hand side, this is winter, and on the right-hand side, this is summer. So during the Northern Hemispheric winter, the North Pole will receive more moisture in the future, the models are showing. And in the Southern Hemispheric winter, which would be the Northern Hemispheric summer, they're projected to receive more moisture as well. Now you can see the ITCZ, or the Intertropical Convergence Zone. You can see that there's areas here that are going to receive more moisture. And on either side of that, you're going to see more drying, a drier situation. So, and you can see where our current deserts are, like over here in Africa, over here where it's real dry in Arizona, Vegas, that kind of idea. Over here in Southern Africa over here too, during their winter, because that's in the Southern Hemisphere, they're going to receive less moisture than they already do. So what this brings the point here is that, I don't know if you guys have heard this term, but wet gets wetter and dry gets drier with climate change. I don't know if you've heard it, but if you have or have not, this kind of is going to drive home that point. The areas that right now are somewhat dry, or more drier areas of the planet, are going to get drier, and the areas that are more wet and receive a decent amount of precipitation, they're actually going to get wetter. But the reason why I'm bringing this up is what does this have to do with the soil, and how is that going to affect our soil reservoir? So precipitation impacts on decomposition. It will happen, but it's hard to predict. So I kind of wanted to point out that I'm going to kind of go over this a little bit, but it is hard to predict. It's hard to measure as well. Precipitation will impact decomposition, and decomposition, so decomposition generally increases with increasing moisture until soils are waterlogged. So basically, with more moisture, there's going to be a higher rate of decomposition, and up until a point though. Once it becomes waterlogged, then the amount of decomposition with moisture is going to remain the same, or it's not going to decompose as much. What they found is that actually periods of drying and wetting cycles can actually increase decomposition. And the reason why is because the rain will break up these aggregates, the aggregates that are kind of clumping together. And when that happens, it allows microbes to be able to get into the clay aggregates, meaning that they're open for microbial attack. They're able to, be broken down by decomposition. When it's a wetter atmosphere, when there's more moisture, there's the death of some microorganisms, which releases the labile carbon. And remember, that is the carbon that is more attractive to these microbes, that they like to actually, consume, and obviously, therefore, decomposition can happen. And that's as long as they don't get waterlogged, it will continue to accumulate carbon. So, more moisture, higher rate of decomposition, diminished efflux with number of drying and wetting stages. Now, the length of the dry season could also be important as well. These drier areas that we went over in the last slide, if they're dry for a lengthened amount of time, that also will affect decomposition. And then also freezing and thawing periods will affect decomposition. Because, if precipitation is going to be falling on, a frozen or a thawing area, then it can cause it to thaw, the way, and then that'll affect decomposition. So, these things are very hard to predict. They're very hard to understand what's going to happen in the future. We do know, though, that with more moisture, there will be more decomposition. Well, when we look at it in a laboratory versus the field, here on the left, we can see that in the laboratory, and then on the right, we can see the field. Now, this is the y-axis is going to be respiration. So you can see that in the laboratory, it raises, and there's going to be a peak respiration as the temperature gets higher, but as the temperature goes up after a certain point, it's going to diminish. You're not going to receive as much respiration anymore. But in the field, you're just going to kind of see as the temperature goes up that the soil respiration is going to just go up. So there's a discrepancy between when we do things in the lab versus when we see them and observe them in the field. So it's another thing. It's just real hard to predict exactly what's going to happen with respect to this. Now, I'm not really going to go into this very much, but this is, temperature sensitivity is often expressed as this Q10 value. Don't worry about this equation right here. But the main thing here is going to be that often we assume that microbial respiration has a Q10 of 2, meaning the respiration doubles by raising the temperature from 10 to 20 degrees. So with an increase in temperature, they're showing an increase in sensitivity to temperature. So if we go over here, then this is also determined by compound type. So recalcitrant compounds are particularly sensitive. Recalcitrant carbon, is going to be the refractory carbon, the type of carbon that's not very attractive to microbes. These are the ones that are going to be more sensitive to temperature changes. But as the temperature increases, then the labile citric acid or the labile carbon is going to increase by 2 times, and the more recalcitrant is going to increase by 3 to almost 5 times. So there could be more than doubling if the temperature increases, and more breaking down of organic soil carbon. That's what the implications for a warmer climate really mean, because if the decomposition rate is going to go up, then we're going to have a higher rate of breaking down of this organic carbon. Okay, so the sensitivity to organic matter depends on some things in the environment. So this is kind of a complicated, graph here, but basically just kind of think in the Y. That this is going to go over the more sensitive organic matter is to change in temperature. So, the higher on the Y value is going to be where temperature really matters, and then down here the lower is going to be where temperature doesn't matter as much. So if you look here, we have things that are frozen are going to be where the temperature doesn't matter very much, but when they're unfrozen, the temperature is going to matter more. And there's a couple of these other things, like if they're aggregated or unaggregated, or anaerobic versus aerobic. So you can see here that the decomposition depends on some environmental factors as well. Now, we currently do not know the overall response of global carbon stocks. This is very open to debate, or an open area of study. And so basically, we do know that there is going to be an impact. It's probably going to result in increased CO2, but we don't know exactly how much. But that's going to kind of transition us into a couple things, or a couple slides I have here on land use change and its impact on the terrestrial carbon cycle. So this is going to be a graph here where we can see different areas of the world, and along with the annual net flux of carbon per year, the year on the bottom here. And South and Central America, you can see, has grown in time, where the annual net flux is increased. This is going to be the net losses of carbon from that region. So basically, if they got rid of a forest, the flux is going to go out of the soil and into the atmosphere, is what this is showing. So in South and Central America, they're doing a lot of deforestation. They're getting rid of a lot of forests in order to make way for pastures for livestock. And so you can see how, this flux is going to change, and, we're going to receive more carbon in the atmosphere. Okay, so here's like kind of another way of looking at it, but instead of it being by region, it's going to be by global or tropical. And you can see that the tropical increase is going to be, increasing quite a bit. I mean, a lot of this global, at this point since 99 on, is going to be due to tropical increase. And that is pretty much going to be land use changes, where they're cutting down the rainforest in the tropical regions. So you can see down here, they actually put it in a table what the actual numbers are. And so the emissions from fossil fuels are going to be 320, where the emissions from land use change is going to be 156. So it's basically going to be about half of the petagrams of carbon per year. So I gave you guys an article to read for this week's reading. I have a reflection for you guys to do on that article. I did upload some information about the final paper. And I also, on November 29th, I'd like you guys to give me your final paper topic and the sources that you'll be using for it. If you guys have any questions, please email me. But as for that, I hope you guys have a great day and a great week. And I will see you guys next week.